Today, I'd like to welcome Dr. Horacio Ferriz to the DeepPower podcast. Dr. Ferriz is a professor of applied geology at California State University, Stanislaus. He is a geological engineer by training with degrees from Mexico's National University and Stanford University, where he received his master's and PhD. He has more than 20 years of professional geologic, geotechnical, hydrogeologic, and environmental experience. Over this time period, he has worked as a geologic problem solver in projects throughout the world, involving water supply, civil works design, environmental engineering, solid waste management, geothermal exploration, and mineral exploration. Dr. Ferriz, welcome to our DeepPower podcast.
Thank you very much. Thank you, Andrew.
It's a pleasure to have you. So tell me, how did you become interested in the field of geology, and when did you know that interest would turn into an academic or professional career?
Well, it's kind of an interesting story. I was born in Mexico. I grew there. And like all Mexican boys, I was expected to play soccer. But I'm not very good at it. So I was always the last one to be picked, always got set as goalie. And being the goalie is a no-win situation, right? And then somewhere in my early teens, I discovered mountaineering. And it was the perfect sport for me because I am a curious person. It is not a competition sport. And I found that I could walk faster and farther than anyone else. So I took to mountaineering with a passion. And by age 15, I had already climbed all of the Mexican volcanoes, had gone down into caves, had walked, hundreds of miles on the landscape of central Mexico. And then came a decision time. In Mexico, you decide what you're going to study in your junior year in high school, because in your senior year, you're already taking some specialized courses. So I knew that I didn't want a job that would keep me in a desk. I would just die. I wanted to be in the great outdoors. So I asked around, and geology was high in my list. The other one was veterinary medicine, because veterinarians work in the outdoors. So I looked at it and thought, oh, geology, this is perfect for me. I'm going to be looking at mountains. It's a good job. So I decided to study geology. And in Mexico, you could study geology in the School of Sciences or in the School of Engineering. And I decided to go to the School of Engineering. So my degree is as a geological engineer. And that means I use my specialized knowledge of the earth to solve problems that are relevant for society. I don't get to choose the problems. Society chooses the problems. I just get to find a solution to that. And I loved it. It is a challenging profession. I don't walk in the great outdoors that much anymore. I'm getting older. But I can still walk my students to their knees. So even if I am slow, I am much better than they are at walking in the mountains. Yes, so that's how I got interested in geology.
And when did you that's a long road to get your master's and PhD. You were in Stanford. What career you stayed specifically in academics, and I'm curious for others that are interested in this industry, what other opportunities with your background could there be for others in industry versus academics?
I am going to correct slightly what you mentioned because I have had a lot of industry experience.
Sure.
I just recently, I went back to academics. When I was studying in the University of Mexico, Mexico was derived a lot of its public wealth from oil and gas. So we were trained to work for the oil and gas industry. And in fact, our field experience, which is a part of every geologist training, was done under the wing of Pemex, the government-owned petroleum company of Mexico. So I was almost ready to go to work with Pemex. I understood very well what they were looking for. I knew how to find it. But then I got offered a job at Mexico's nuclear power agency. And I thought that was so cool, because it was developing a new resource. At the time, foolishly, we thought that we could develop a portfolio of power sources by oil and gas, big thing, but also have nuclear and geothermal and hydro. Of course, we have had hydro for a long time. So I started working with the nuclear agency. We found some very good uranium deposits, but then, of course, we should have realized that our neighbor to the north was never going to let us develop that nuclear capability. And about that time, I decided that I wanted to do graduate work. So I wanted to go to France because France was kind of at the forefront of nuclear power development. But the company said, no, we have too many people have gone to France. Go to the United States. And I was a little miffed. So I said, okay, I'll go, but only to the best university. Which is the best university? Stanford. Okay, I'll go to Stanford. And I didn't know that I was supposed to apply to a whole bunch of universities, right? I only applied to Stanford and I got in.
Wow.
At the time, Stanford had one of the few applied geology departments because they were big into the applications to oil and gas, to mining, to hydro, to development of water resources. So I did my master's degree in mineral exploration and remote sensing because by that time we were beginning to have the first Landsat satellites. And then I changed for my PhD, I did it in volcanology and geothermal exploration. So I came out of my PhD and I started looking for work. And at the time, the environmental geology industry was the place to be. So I did a stint as an environmental geologist. Not very exciting, if you ask me. And then I went to work with an engineering company whose specialty was the construction of landfills. Now, I know landfills don't have a very good reputation, but they are pyramids. We're the modern pyramid builders. We're making these enormous structures. Normally, we put them on a slope over slick plastic. So there are many issues in terms of stability. And of course, landfills contaminate groundwater. So I had to teach myself all about groundwater, all about hydrology. And I worked on that for about 10 years, eventually moved to the Central Valley with the same company. And after a couple of years, I went independent. I have my own little consulting company. And that felt like I was going to step off a cliff. It's like, oh my God, I'm not going to have a salary. I'm going to have to bid out of my wits. It was not bad. It was more like stepping down the curve. But of course, being a consultant and looking for stuff to do, the university contacted me. And could I teach a specialty class, hydrogeology, for them? Sure, I do things for money. So I taught a class, and they liked me so well that they offered me a full-time job. And for the last 20 years, I have been teaching applied geology at Stanford State, which includes applications to the exploration of oil and gas, applications to geothermal exploration, to mineral exploration, to water supply, and to the construction of civil works. We don't build the civil works. The civil engineers do that, but we're the ones that advise them what kind of ground they're going to be working on. And I know I am talking a lot, but I'm almost done with this part. Because of my emphasis, because I have experience working, I can provide to the students a unique perspective that academicians normally cannot, because I have been in the trenches and I can tell them exactly what is expected from them. So I have been very successful. Most of my students have gone to the workforce and are now in good positions. A few have gone to graduate school, but very few, because the working degree for a geologist is the professional license. Just like a doctor or a civil engineer needs a license to practice, geologists also need a license to practice. Anyone can kick a rock, but if you're going to kick it for a client, you better be licensed.
Yeah. I love that. Well, I like that as a child, out of your adversity to not be good at soccer, you found a different passion and almost a superpower, which really steered your love for nature and hiking and mountains and rocks. So what a interesting and fascinating background. And I love to hear how you came to be where you are now. I heard you mention different forms of energy, nuclear, hydrological, geothermal. Question for you. The panic to move away from fossil fuels is really putting a strain on other resources from the earth, such as lithium, cobalt, etc. Do you feel that panic to move away from oil and gas is warranted? And I know that's kind of a political question, but maybe more so from your experience as a geologist.
No, I don't think it's warranted. I think we are in panic, and any decision that is taken in panic is likely to be weak. Um, First of all, we're in California, right? We are the beautiful people. We're clean, so we want to use electric power. We don't realize that electric power is being generated outside of California by coal-fired plants, by petroleum-fired plants, by large hydroelectric plants. We just figured that since we have the money, we'll buy the power and we'll be green. So the first thing I like to point out to people that want to go electric is that yes, but somebody has to generate that power. California doesn't have enough power generation facilities. And we saw that last year when at the peak of summer, we ran out of power. We had the brownouts. And I just figured that if you're going to rely on electricity to say, move yourself in vehicles, and the electricity goes out, then you are stuck. I like the idea of a diversified portfolio. And I'm not a prophet of any type. So in a diversified portfolio, if you want to rely on A or you want to rely on B, hey, that's your choice. And most of the time it comes down to money. I have looked into installing solar panels here in the house. It's a small house. And I am surprised that I never get a price. I get all sorts of marketing stuff, but they never tell me it's going to cost this much. And I go with the old idea that if I have to ask the price, I cannot afford it.
Yeah.
Well, I spend about $1,000 a year in power. My sister and her husband recently installed solar. So I said, okay, tell me, how much did it cost? Well, come on, talk to me. 40,000. It would take me 40 years to amortize that expense. Yes, but we're getting a tax credit of 15,000. Okay, so now it will only take me 25 years to amortize that amount. And yes, but your costs are going to go up. Yes, but your interest is going to kill you because this money has to be paid back to the bank at some point. So it's not that cheap. Do I think that coal burning is a good technology? Probably not the best. However, we have made great advances in the scrubbing of the emissions. So we can produce reasonably clean emissions. Same thing with refuse to energy plants, which are a good way of saving landfill space. We scrub them very carefully so that it is not this enormous amount of pollution. Gasoline, diesel remain the best portable source of energy. Where else can you have a suitcase size of energy and move it around? For the big things, nuclear and hydro. Nuclear is great base power because once you start it, you just let it go. Hydro is a lot more controllable. You can turn it on when the peak comes, so that's very good. Geothermal has puzzled me now for 40 years, and because in some regions it can make a significant contribution to the power portfolio. It is not cheap, The investment is high. Investors have to be willing to take that risk. But for some locations, it is a very decent source of power. And then finally, wind. Wind is great. However, the problem is that wind blows, the strong winds are in the night when nobody's using the power. So either we use that power to pump water up into a reservoir for pump storage, or we start mushrooming batteries. And I don't like the idea of batteries. As you said, lithium wars and nickel wars are going on right now. And at some point, I know me, I'm not the greatest homeowner. If I had a battery the size of a refrigerator and it went out, it would probably stay in the garage and it would age in there and decay probably because I'm not very good at repairing things, you know. So I believe we should have a diversified portfolio. I would not like to see reliance on just one source.
Yeah, I think those are very valid points. And what's interesting is public perception, largely guided by media campaigns, really doesn't explain the pros and cons of all of these, where you have, people are still freaking out about the carbon emissions to our atmosphere from fossil fuels. And while that is true, and there's no other industry on the planet that's probably governed and regulated as heavily as the oil and gas industry, right? So when you're drilling, the regulations to put every grain of soil back or to make it better than when you left it, there's a lot of regulation that prevents and protects our environment, our neighborhoods, whereas other forms of energy aren't quite there yet. For example, like I said, lithium, the lithium and cobalt wars, as you mentioned, I think humanity's turned a blind eye to the impact on the earth that lithium mining has. And, cobalt mining in the Congo is killing just countless lives because it's unregulated but it's clean and it's green, right? So I agree with you. There needs to be a diversification. The public needs to become more aware of the pros and cons. The funniest thing I see now is cars being powered by a portable diesel generator, right? Electric cars, excuse me. And I just laugh because it's like, you guys are just, it's okay to run a diesel generator to power an electric car, right? And it's public perception. But I agree with you. There are major issues that need to be addressed before we can really just move away from fossil fuels. And I was talking to a petroleum engineer at the University of Oklahoma 2 days ago, and they said, if we understood how much oil and gas is used to produce plastics, not even drive cars, there's no way our civilization can get rid of that industry because of how dependent we are on even just the plastics, right? The byproduct. So anyways, I think it's interesting. Another question, several years ago, you had mentioned that you were part of a geothermal exploration project. I'm just curious, what was some of that history and your experience at that time?
Well, I was working for the Federal Power Company at the time, and they were looking into diversification. Mexico is cut in two by an east-west volcanic belt, the Mexican neovolcanic belt. And of course, it's common to have hot springs and evidence of hot water. So I think the Italian government was the first one to bring it to the attention of the power companies, like, hey, there's a resource there. So we thought, yeah, there's a resource there. Now, part you could do from your desk by looking at a map, because they have names like Los Azufres, the sulfur emanations, or Los Humeros, the smokes. And so it was relatively easy to find places where there was active hydrothermal activity that we could start looking at. So I ended working in Los Humeros, in the eastern part, central eastern part of Mexico. And in a very cold morning, you could see little wisps of steam rising from the ground. The locals, in fact, used to dig a hole and use it as a temazcal, as a steam bath. They would jump in there and cover themselves with a little plastic or or something and take a bath that way. So there was obviously hot heat in there. The question was going to be how deep and in what amount. At the time, I was working on my PhD, and I was in charge of mapping that whole area, which is a little bit like Crater Lake. You know, it doesn't have a big lake in the center, but it's a caldera system. And we know that those caldera systems are oftentimes broken rocks, but they are filled with volcanic deposits that easily alter and create a cap. Because for a good geothermal system, you want something that is capped, that is not just losing its liquid. You want a few wisps of steam because those are the cracks that tell you that something is there. So we were ready. We were going to drill in a volcano, a big volcano, a big white volcano. We were convinced that volcanic activity had ended a few thousands, tens of thousands of years ago. But before you drill something, I mean, we were looking at 1,000, 1,500 feet of drilling. So it was not going to be just little holes. It was going to be regular, oil industry type of a hole. Before doing that, we decided to do geophysics. And this is geophysics in the grand scale. We were doing resistivity lines that were kilometers long. I mean, we had ATVs and walkie-talkies, and one ATV would go that way 5 kilometers, and the other one would go that way 5 kilometers. Okay, we're going to turn on the generator. Step back. Oh, everything with the radio. And what we were looking for was either a very low resistivity, because hot saline liquid is a very good conductor of electricity, or a pod of very high resistivity, because steam is a very poor conductor. And in the ideal world, we wanted to hit a steam pot. Well, no, there was no steam pot. But there was hot water, and you model this thing, you create a mathematical model, and we figured that yes, 1,000 to 1,500 meters was the depth of the likely depth. So the first hole went in, and bingo, we hit hot water. Now this is hot water that was hosted by very hard rocks, andesites, that were fractured. Ideally, I mean, in the perfect world, you find yourself a sand that has the hot water in the pores, because that would be a type of reservoir like the geysers. The geysers is in sand, so the steam is in the little pores of the sand or in cracks, but not in this case. In this case, we had a very hard rock, and the steam the hot water was going to be in the cracks. As you well know, what we do is we bring the hot water to the surface and then flash it into steam on the way up, and then use the steam to push turbines. We were not doing double cycle or heat exchange or anything. The idea was just to put it in the turbines right away. So we did, and well, I didn't. I was the geologist. That's something that engineers do, particularly gas engineers that train in the oil and gas industry for gas. They're the ones that are really good at handling steam. It's a gas. And I don't know, we generated 200 kilowatts, which is a tiny amount, really, in the grand scheme of things. So more wells came in. This was happening 30 years ago. I was recently there last year, and I think I saw well 40. So clearly they have been continuing to drill. Are we generating a lot of power from that site? Not really a lot. I think my memory may not be right, but I think we're generating 5 to 10 megawatts, which is a relatively small amount. we have learned a lot about how difficult it is to handle hot saline fluids because of corrosion problems, which is something that I think you guys are working to alleviate to a certain extent. Moving the steam around is a trick because it is corrosive, so all the piping has to be continuously be renewed. And we also were concerned about the fact that when you extract hot water, you're extracting heat, so the enthalpy goes down, and you need to let the reservoir rest so that new water can come in and heat up again. And at the edge of Mexico, you have the drop to the coast ranges, so you have a lot of rain. And we were concerned that cold rain penetrating to the reservoir could actually decrease the whole enthalpy of the system. Now, I don't know exactly what the operational plans are nowadays, but I know that in Nevada, in steamboats in Reno, they are very careful as to where they pull the hot water from and to let it rest. So it's a little bit like you are rotating your crops to make sure that you maintain your enthalpy, your heat content high. And I think that was one of the lessons that we had to learn in those early years of exploration.
Yeah, and how long ago was that, you said?
That was in 1984. And it really accelerated in the late 1980s, early 1990s.
Yeah, so 30, 40 years ago, I mean, you were doing things that, the industry didn't know if it was necessary because oil and gas was so much easier to get. But you touched on a few very important points that I think the industry is still experiencing those same challenges. As you mentioned, how do you get through hard rock? How do you deal with the corrosive environment down there? How do you handle such hot water? And I think these are now the same challenges, but technology is allowing us to progress a little faster. And I think it's interesting, again, back talking to some of these oil and gas professors at University of Oklahoma, they had mentioned how, 10 years ago, fracking wasn't even really known or widely used. And within a 10-year period, the advancements in technology and fracking became so sophisticated that, people were extracting oil in places never thought before. And I think his illustrative point he was trying to make was in a 10-year period, massive advancements can be made. And, there's some studies that show that by 2050, geothermal will only make up 2% of all, alternative energy sources. And while at the time that study was done, I think that's true. I think that there's becoming a larger adoption and interest in geothermal. And if, like fracking, in a 10-year period, technology and energy can be pushed, I think a lot of advancements can be made. Will it be our only source of power? I don't think so. To your point, it behooves us as a society to have hedged alternatives in case of problems. But what I love that Mother Earth has provided us a gift with an always-on source of energy as hot as the sun, beneath our feet. And one of your expertises, I know, is volcanism, which I'll ask because I see you're wearing a volcano shirt. And there are places like Iceland where 80-90% of the entire island is heated by volcanic geothermal heat, right? And in places where there are volcanoes, those areas have that advantage. But for the rest of the planet, what really has to happen is you got to be able to drill 6 to 8 miles deep into the earth. That's a massive feat. There's tons of pressure, tons of hard rock to get through, and no one's done it yet. But here at DeepPower, just as you mentioned, we're focused on new drilling technology to allow us to drill faster through hard rock. We've just had some simulation studies that show that our technology can increase the rate of penetration over traditional drilling technology by 600%. And I know there's been some exciting news about millimeter wave technology, but our studies are showing that we could even improve rate of penetration by 300%. So we're very excited about that. We're also focused on, as you mentioned, corrosivity and how do we coat the pipes and the metal so that it can withstand or prevent as much of that as well as casings. Once you cement the well, there's a lot of expansion and contraction. So that's our focus at DeepPower. It's a big, noble cause. It'll take us a little while to get there. But for other places on the planet, I know people are interested in volcanism. It kind of sounds like a Star Trek, civilization, the Vulcans, right? Volcanism. What is volcanism, planetary volcanism? Why does that interest you so much? What opportunities are there to leverage kind of the environment around volcanoes?
Well, of course, volcanoes are beautiful and they are dangerous. So those things attract us very much. Um, my well, I have two interests in volcanism. One of them is to understand the physical processes that cause it. And you were saying about advances in your computer modeling. We also have had those type of advances. So we're understanding more about the physical process. And we deal with a very interesting substance, magma, which is at ridiculously high temperatures. It's viscous, it's pasty, it vesiculates very energetically with a bang. Um, a more direct application to society is there's many places in the world in which the volcano is the mountain where the water is. So people have the tendency to live close to the volcano because the soils are fertile, because that's where the water comes from. And they're putting themselves in danger, not because they want to, but that's because they can make a living. So we're particularly concerned about trying to figure out ways to protecting those small towns, at least give them a heads up and say, hey, it's time to go visit Aunt Matilda because you don't want to be here for the next month. So that's something that concerns me quite a bit. 30, 40 years ago, we also, the U.S. Geological Survey was looking into tapping magmatic heat in Hawaii. It was all a cartoon, but we figured that we could drill close enough to the magma chamber. The magma is at 1200 degrees C. You get close and you easily get into your 400 degrees C or more. And I don't think it advanced because we didn't have the technology, because what we had was just not suitable. You are correct in saying that now with the new materials, material science has to be super important for what you are doing. And in general, we need to take advantage of all those new space age materials that are being developed all the time, because they are designed to withstand pretty aggressive conditions. I also have interest in planetary volcanism. I think you mentioned planetary somewhere in there. Planetary science in general fascinates me. And I must confess that I was a complete ignoramus on that. And then several things happened close in a row. There was a good book published about planetary science, so I bought it on a lark. The movie The Martian came out. And one of my students, one of my very brilliant students, mentioned that she was interested in planetary science. And I'm like, okay, the universe is trying to tell me something. I truly need to learn more about this. And the last 5 years have been a fascinating exploration of something that I knew very little about. I know a lot about the one planet, but there's a whole range of other planets. And in all of them, there has been some sort of volcanism. Now, the Earth is very special, it's very unique, because we have active volcanism. In most of the older other planets, well, Venus may have active volcanism, but Venus is a very hostile environment. But the Moon, Mars, Mercury, the volcanism is very old. So we're able to see what the Earth might have looked like 3 billion years ago, because Mars kind of created a museum of that stage of planetary evolution. On the more practical, I don't know if practical is the word, right? We are thinking that we would like to go to Mars. There is not going to be any volcanoes, no problems with that. But Mars is still trying to cool down. It just cannot cool down fast enough because of it doesn't have plate tectonics. So Mars is very cold right now, or very hot if the sun is shining on the one side. But at depth, the geothermal gradient, that is the increase in temperature as you go down in depth, is probably pretty steep. And if we ever manage to put a station there, maybe one of the options that we will have is to try to tap the Mars thermal energy that is there, particularly if a company like yours develops ways in which we can drill quickly and effectively into that hot rock. I also like to see, say, the images of Mars or Venus and scratch my head and say, that's a volcano, but it doesn't look like any volcano I know. What caused it to be different? The pull of gravity, the composition of the magmas, the absence or abundance of water in the magma, all those are factors that I like to think about. I don't know that I can prove any of those of my hypotheses, but it's a very interesting, thought-provoking exercise.
Absolutely. I think if whenever I talk to Elon next and he has a seat for you to Mars, I think your background of hiking and walking, you'd be a great test subject, and you'd probably enjoy exploring that planet, right? It's clear, Dr. Ferriz, that your excitement and enthusiasm for your study is infectious. I would have a fun time being a student in one of your classes because I could see your energy when you talk about things you love, and that'd be fun. I'm sure you'd be a fun professor. I've really enjoyed my time getting to know you and learn a little bit about you and your background and your research. I appreciate that time. For my audience who is learning more about geothermal, it's extremely important. The field of geology in general is, massively important to our future as a society in terms of energy and obviously oil and gas. And there's so many opportunities if you study that. I was a kid picking up a rock and throwing it. And I think a lot of kids like rocks, and most kids don't realize you can have a career, playing with rocks. So appreciate your education on that. I look forward to continuing to speak with you and work with you in the future, and to see where you continue to go and the great things you continue to do. So thanks for your time today. It's been a pleasure.
Well, you're most welcome, Andrew. Thank you for inviting me. I enjoyed talking about this, as you mentioned. And if at some point something happens, an earthquake, a landslide, or something like that, and you want an opinion, I can always give you an opinion.
Absolutely. You'll be on my speed dial. Absolutely. Well, thank you so much. Stay cool in that hot shirt you have there, and we'll be in touch.
Thank you.
Okay.
Goodbye.
Thank you.